Alright class, so now that we've talked about looking at one categorical variable as well as looking at two categorical variables, we're now going to go start looking at the other type of variable, which is our quantitative variable. So we're going to do the same types of things we did for one categorical variable back in this parts 1, 2, and 3 notes, and we do the same types of things now just looking at a quantitative variable instead. So first, just a refresher of what a quantitative variable is. So a quantitative variable was a number, generally speaking, but it was a number that had to quantify something. And so in this sense, when we look at talking about a quantitative variable, it had units attached to it, for example. It's like how many years old I am, or how many pounds do I weigh, how many inches tall that I am. Or another way to think about a quantitative variable is that the difference between two numbers is meaningful to me. So, if someone is 5'4" and someone else is 5'7", so one person is 3 inches taller than the other. That difference meant something. Versus an example where we had something that was numeric that wasn't a quantitative variable was looking at area code. And the example I gave in class, we looked at my area code in Nebraska is 402. But when I moved here to Kentucky, it's gone up to 859, which is more than doubled. So the fact that it's doubled isn't important to me. All it is telling me geographic location, so it's not a quantitative variable. So hopefully now that we remember what a quantitative variable is, we're going to talk about what we did in the part 1 notes for a categorical variable, and we're going to start by looking at numerical and graphical displays. We're going to start here looking at the numerical types of displays for a quantitative variable. So some of these you've probably already seen before, but we're just going to go through them just for completion, really. So for the first thing we talk about is a measure of center. There's two different measures of center we talk about. The first one is the mean, or sometimes referred to as the average. How we find an average, right? We add up all the numbers and divide by how many we have. So if I'm looking at this, there's two different symbols we actually have for an average. The first one I have is Y bar, and the other one I have is mu. Mu we've seen before. This is our population mean. Versus Y bar, we briefly talked about it in the who, what, when notes, but this is our sample mean. So if you want to compare these, when we talk about categorical variables, right, we had P was our population proportion versus P hat was our sample proportion. So the very similar idea that we have here for population versus sample, and just two different symbols to go with this. And again, this one's read as Y bar, so it has the bar on the top. And then again, just as a refresher, how you calculate a mean, right? We add up all the numbers we got. Mathematically, that means I have this cap sigma, which just means to sum, just as it did in our relationship between two categorical variables notes. I'm just going to add up all of my y's and divide by my sample size. Now, I'm not going to actually make you calculate a mean. We'll do one as an example here in a little bit, but most of the time I'm going to provide you this number and we're going to focus on interpreting it. Next, our other measure of center is called the median, which again you've probably seen before. This is just the middle value in your data set. And of course, when I'm talking about the middle value, things have to be in order when I'm finding a middle value. And there's two different things that can happen here. If my sample size is odd, there is going to be an actual middle number. So the median will literally be the middle value. Whereas if your sample size is even, and maybe some of you had to find a median before where you start kind of crossing numbers off on each side till you arrive at the middle, if n's even, you don't end up with one middle number, you end up with kind of two numbers at the same time. And what we do to find that is we average the two middle values. And again, I'm probably not going to have you actually calculate this, but it's one of those understanding things to understand that. So for example, if I'm looking at the median number of children in a household, I could get 2.5. And the way that's happening is probably averaging two different numbers to get yourself there. Some other numerical measures that we're going to talk about is we have the max or the maximum, which is of course your largest value. The minimum or the min, which is your smallest value. And you've probably seen those before. Probably new to you are these quartiles. So we're talking about the third quartile and the first quartile. But first, to remember what those are, I'm going to go ahead and talk about percentiles. So remember, we've seen percentile back in the normals note. And so if I had the kth percentile, so if I have the kth percentile, k percent is at or below it. So the reason why I bring that up is quartiles are a certain percentile. So the third quartile is the 75th percentile. Now when you think about this, so quartile makes you think quarters, right? And thirds are kind of 3/4. That's where that 75 is coming from. So the 75th percentile, so 70% of the observations are at or below that number. Versus the first quartile is the 25th percentile. So kind of one question that I actually don't put here and hopefully makes sense is, what's the second quartile? If I think about what the second quartile is, it would be the 50th percentile. So what number has 50% of the data at or below it? That's technically what the median is. So it has its own special name. That's why we don't just call it the second quartile. The median literally is the second quartile, because 50% of the data is below it, 50% of the data is above it. That's sort of how we define the median. And then some other measures that we're going to talk about is we're going to talk about this 5-number summary. The main reason I'm bringing up the 5-number summary is when we talk about a graphical display, you're going to see something called a box plot that you may or may not have seen before. The 5 numbers used to create this are the maximum, the third quartile, the median, or again, if you technically want to think about this, that's actually your second quartile, the first quartile, and the minimum. So when you look at this, you start at the minimum, 25th percentile, 50th percentile, 70th percentile, and then technically the max would be the 100th percentile, because 100% of the data that we had would be at or below it. So kind of 0, 25, 50, 75, 100. So kind of how we use to create a box plot. So kind of breaks your data into quarters. So there's going to be 25% of the data between the max and Q3. There's going to be 25% of the data between the Q3 and the median. There's going to be 25% of the data between the median and Q1. And then there's going to be 25% of the data between the Q1 and the minimum. So just kind of breaking your data up into 4 quarters of equal number of observations between them. Now we also want to talk about measures of spread. So the first one you've probably seen before, which is the range, which is just your maximum minus your minimum. It's one of the first ones we talked about because it's one of the easiest ones to calculate and for students to truly understand. Now we can go a little bit further since we're in college at this point. So we have the interquartile range, which is Q3 minus Q1, or basically we'll give you that middle 50% of your data. So it's a little bit more helpful than just the range where you have where your entire data falls between, but kind of where's that middle 50%. So this can be a very useful thing, for example, for exam scores, kind of have that middle 50% that students do on the exam. Another one that we've talked about a little bit, but not a ton yet, is really this idea of a standard deviation. And so first, I'm not going to give you the formula for standard deviation because I'm never going to make you calculate it, and it can be somewhat hard to understand. So what I want you to understand more is what it's measuring. So the standard deviation measures the typical distance an observation is from the mean. And the important thing here is that it's from the mean, not from the median. So this is always measuring the typical distance from the mean. The larger the standard deviation, the more different our values are from the mean. finally, we've had a symbol for standard deviation. We've seen that Greek letter, little sigma. And that technically represents the population standard deviation. You can probably guess where I'm going with this. We're not always going to have the population standard deviation. Sometimes we're just going to have a sample, and we can actually calculate the standard deviation of our sample. So we're going to have a new symbol here for our sample standard deviation. That's just the letter S, of little s technically. And that's going to represent our sample standard deviation. So kind of your new symbol alert is this S that we have here. And to somewhat understand standard deviation, we're going to look at 3 data sets and sort of compare them. So my first data set is going to consist of the numbers 20, 20, 20, 20, and 20. Not a very exciting data set. My second data set is going to be a little bit more exciting. This is the numbers 14, 17, 20, 23, and 26. And finally, my third data set we're going to look at going to be the numbers 1, 20, 39, and 39. Alright, now, so of course, I gave you data sets to give, a certain lesson here. So let's first talk about, for each of these data sets, I can calculate my mean. Or in a sense, my y-bar here. So I'm going to add up all my numbers, 20 plus 20 plus 20 plus 20 plus 20, divide by how many I have, which is 5. If I have no shocker to this first data set, the mean turns out to be 20. Do the same thing for data set 2, add up my 5 numbers, divide by 5, I get 20. Add up my last 5 numbers, divide by 5, I also get a mean of 20. And I did this intentionally, so each of these data sets have the exact same mean. So if all I report to you is the mean, that really is not describing this data very well. Right? There's a lot going on in this data I'm not really explaining by just saying, well, the mean was 20. Right here, everyone was exactly the same. Here, they're a little bit different. Here, they're a lot more different. Now, understand how that relates to standard deviation. Typical distance and observations from the mean. The larger it is, the more different the observations are from the mean. Well, these observations aren't different from the mean at all. Right? They're exactly the mean. Which is actually why if you calculate the standard deviation for that data set, it's 0. Because with the typical distance, it falls from the mean, 0. Now for data set 2, the values are different from the mean now, so it's not just going to be 0. They're not too far away from the mean. And I just got this number from StatCrunch, which I'll show you how to get these numbers from StatCrunch in a moment. I get 4.743. But this last data set, the values are much more different from the mean. Right? They're ranging from 1 to 39. They're a little bit more all over the place. Here, the standard deviation turns out to be 19. So again, the larger the standard deviation, the more different the observations are from the mean. Right, so I mentioned a lot that I'm not going to make you calculate these things by hand. So I want to show you how to get these in StatCrunch. So we're going to be using a data set that is out on Blackboard for you all. It's looking at the PGA data, which is professional golfers. This one has 3 different variables in it. We're going to focus on this one, which is their earnings. And so I'm looking at how much money these people earned. It's going to be quantitative, right, because it's the actual amount of money. So I have that unit attached to it. So the first thing what I want to do is pull this data set up into StatCrunch. So I'm going to open my StatCrunch. I'm going to select a file on my computer. I have mine saved on my flash drive here, so you could download it from Blackboard and then save it somewhere so that you could load it as well. Okay, I can give you a little snapshot of what it's going to look like coming in. And hit my load file. Now the next one on our notes does have a little bit of StatCrunch directions here for you. So I loaded the data. I'm going to go to Stat, Summary Statistics. Make sure I'm not making work at the moment. There we go. So we're going to go to Stat, Summary Statistics. And then what you choose after this depends on how your data is organized. Since my variable is a column, I'm going to choose the Columns option. Then I have to click which variable I want that information for. So I just want it for my earnings. I'm not going to worry about my other variables right now. Then down here it tells you everything it's going to calculate for you. So the first thing I'm going to do is actually get rid of the ones that we haven't talked about so that it doesn't confuse me. I'm going to get rid of variance, which I did by control clicking there. And there is a difference between standard deviation and standard error. So to keep myself from being confused here, I'm going to get rid of that standard error because we haven't talked about it in the quantitative sense yet. Median, range, min, max, Q1, and Q3 are all things we've talked about, so I can leave the rest of them here and hit my compute. So I can get all of these different numbers. The one I didn't give you in your output and your notes was the range, which you can calculate the range from the min and max. Then to actually just get that into Word, I did Options Copy, and that's going to kind of tell you. So you just need to hit Control A, and that will copy everything. Control C will then actually copy it. If I hit Control A, it highlights everything. Control C would copy that, and then when I come over to Word, I can just hit Control V, and it would paste that in for me. Alright, so now actually looking at using those numbers. So we got a mean of 1,263,218, a standard deviation of $1,249,089. The median looks like I got off a number that it should be a 0.8 there, which I'm not sure why it's not there. So I'll make sure I change that in your guys' notes. So hopefully it's 831,089. So this should have been the decimal that I was rounding for you all. Our min and our max, Q1 and our Q3. Now what I'm mainly bringing this up for is if I'm not going to make you calculate standard deviation, we would really like to know what that number is really telling me. So standard deviation is the typical distance a point falls from the mean. So let's start at the mean. Right, so our mean is 1.263 million. I can kind of add the comma there if you'd like. So I'm going to go out one standard deviation. I'm going to do that. So doing it the same way I've done before, I'm going to take my mean and subtract off that number to get down here, which is $14,129. I'm going to take my mean plus my standard deviation to get up here. So that's $2,512,307. So mathematically, we've done something like this before, but now I can actually interpret that, and that's going to tell me something. So I could then say that the typical earnings were between $14,129 and $2,512,307. So that's how I'm actually going to interpret my standard deviations, by actually going out a standard deviation in both directions and then interpreting it as if it's for the typical value is. I'm not saying everybody, but this is where the typical person's value is going to be between. Alright, so some other important things here, a little kind of refresher, some of the symbols. These first two are, again, pretty new. Technically I've seen it before. brand new for us, this is still going to be showing up. Our sample size is still going to be showing up as well. And this is a reminder that when we calculate a statistic is a numerical summary calculated from the sample. So all of these things up here that are labeled as summary statistics are called that because this is a sample of data that we have here. These are all sample values. This is a Y bar that I have here. This is a S, or the sample standard deviation. So just kind of refreshers about some symbols and a little reminder there. And then in class next, we're going to talk about graphical displays for a quantitative variable.